Alright, here is my reassessment of chapter 22.1, which is dealing with Gauss's law. And Gauss's law relates the patterns of electric field over a closed surface to the amount of charges in that closed surface. And the patterns of electric field over a surface can be measured using electric flux. Electric flux is the amount and direction of the electric field over an entire area. The electric flux is written out here, which is equal to the integral of the closed surface of electric field dot n hat times the derivative of the area. And E dot n hat can also be written out as E times n hat times the cosine between the two. And n hat is always perpendicular to the surface that we're integrating around. And if the angle between the two is 0, so they're parallel to each other, or going to the same direction, then we can simply write it out as electric field times the area. So here we're going to find the total flux on the cylinder right here. So we have an electric field going to the right into the right side of the cylinder at 1600 Newton per Coulomb, and coming out of the cylinder at 1000 Newton per Coulomb, and it has a radius of 10 centimeters. So first we can find electric flux just on the left side, which is, since they're both going they're parallel to n hat is perpendicular to the surface. Electric field is going the opposite direction. They're parallel to each other, or the angle between them is 0, so we can simply state that electric flux is equal to electric field times the area, which is equal to negative 1600 Newton per Coulomb times the area, which is pi r squared, so it's pi times 0.1 meters squared, and the electric field is negative in this case because it's going the opposite direction of what n hat is. So if the electric field is going in, then it's negative, or if it's going out, it's positive. So here the electric flux on the left side is equal to negative 50.27 Newton per Coulomb meter squared, and electric flux on the right hand side is going to be positive because it's going with n hat perpendicular to the surface or going outward. So we have 1000 Newton per Coulomb times the area, which is pi r squared, 0.1 meters squared, equals 31.4 Newton per Coulomb meters squared. And to find the total flux on the cylinder, we would simply just add up everything. So here, the total electric flux is equal to electric flux on the right plus electric flux on the left plus electric flux on the side. We didn't calculate the electric flux on the side because on the side, which is just all around the side of the cylinder, where electric field is parallel to the surface, because it equals 0 because the angle between n hat and electric field, n hat is this way, is 90 degrees, and the cosine of 90 degrees is equal to 0, so it's just always going to be 0, so that's why it has to be perpendicular. So the total electric flux is equal to 31.4 Newton per Coulomb meter squared minus 50.27 Newton per Coulomb meter squared plus 0 equals negative 18.87 Newton per Coulomb meter squared. Now this means that there's a total of 18.87 Newton Coulomb meter squared hitting the cylinder over an entire area, and it's negative because it's hitting into the surface, going into the surface and not out of the surface. And there is Gauss's law and electric flux.